Hey, this is Mr. Mabrey, and this is Data Notes. In the next few minutes, we're going to talk about different terminology that we use when describing different types of data. Now, I guarantee you it's going to be challenging to learn this terminology, and most of you have never used it before. But remember, knowing these terms is important because we're going to need to use these terms when we look at our data, and these terms are going to help us understand whether or not we're seeing trends in it or not. The first term I want to talk to you about is quantitative data. Quantitative data is really data that has numbers in it. This is in comparison to qualitative data, which is data that does not have numbers and is merely descriptive. For example, if we're talking about time, time is full of numbers, so it would be quantitative data. But if we're doing an experiment on types of cars, Ford versus Chevrolet, well, there's no numbers there, so that's qualitative data. So remember, quantitative data is numbers, qualitative data is no numbers. The next set of terms is continuous data versus discrete data. And to learn these words, I've come up with a great hand gesture to help you guys remember the difference. Even though you're going to feel dorky doing this, do this with me. For continuous data, stick your hand in front of you like this and squeeze out a line. That line you just squeezed out is a continuum. Continuous data is always found on a continuum, which means it could start here, but it could go here, 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 all the way on this line. Discrete data, by comparison, it's either this or that. Go ahead, do it with me. Discrete data, it's this or that. We're going to be doing these silly hand gestures in class, so you might as well get used to it now. Discrete data is like the Ford or the Chevrolet. Either I have a Ford or I have a Chevrolet. I don't have anything in the middle. That's why it's called discrete data. What's easy to remember is that discrete data is a bar graph. Can you picture a graph right here, or maybe a graph right here? These are your two separate bars on a graph. That's why discrete data goes in a bar graph. Continuous data, since it fits on a line, will always be used in a line graph. That's why it's easy to remember continuous data goes on a line graph. It's on a continuum, which is like a line, which is why you graph it on a line graph. So here's a picture on your screen of continuous data on a line graph and discrete data. If you couldn't visualize it from my hand gestures, if you look now, see here on the continuous data, we've got a point here, or here, or here, or here, or here, or here, or here. We have all these different points on the line. But for discrete data, it's either this bar or it's that bar. Now let's do some examples. We've got time, distance, brands of cake, temperature, types of soda, color, and types of car. What we're going to do is, I'm going to say one, I'm going to pause for 2 seconds, as I want you to try to guess whether it's continuous or discrete, and then I'm going to tell you the answer. You can review this part of the video as many times as you want to practice for your upcoming quiz. So let's start with time. What do you think? Continuous or discrete? Okay, time is continuous because it's on a line. It could be 12 o'clock, 12:01, 12:02, 12:03, 12:03 in 1 second, 2 seconds, 3 seconds. See how it's on a line? Now let's try distance. What do you think? Okay, distance is continuous because again, how far did I go? Did I go 1 inch, 2 inch, 3, 4, 5, 6, all the way to infinity? That's why it's continuous. How about brands of cake? Brands of cake. Discrete. Betty Crocker or the other guy? How about temperature? Temperature is on a continuum. Is it 5 degrees, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? How about types of soda? Good. Discrete. Pepsi or Coke? How about color? Now color is interesting, isn't it? Because color could be continuous, I have a little bit of red, and then reddish green, and then a light reddish green. Think of that color palette wheel on your computer. You could pick all those different colors and keep adding or changing a little bit. But in other scenarios, color could just be discrete. Like, what color of car do you have? I have a black car, or I have a white car. There's green cars over there, or brown cars. So color sort of depends on the situation and context. Now let's talk types of car. Okay? Types of car, discrete. Chevy or Ford. Now, let's talk about qualitative versus quantitative. First with time. Alright, good. Time is quantitative because it has to do with numbers. Is it 5 o'clock, 6 o'clock? Those are numbers. What about distance? Okay, good. Distance is quantitative as well. Numbers. Did you go 5 feet, 10 feet, 20 feet? That's why it's quantitative. How about brands of cake? Good. Betty Crocker, not a number. Must be qualitative. How about temperature? Good. Quantitative. Numbers. How about types of soda? Good. Qualitative. Pepsi or Coke? No numbers. How about color? Good. Qualitative. Red and blue, those are numbers. Types of car? Awesome. Mustang, not a number. So see, this isn't as hard as you thought it was. We're going to keep using the numbers this week as we talk about data, and pretty soon they'll become extremely familiar to you. Thanks.